Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Dear students, this lecture is for grade 8, subject chemistry. And in this lecture, we will discuss the remaining topics of chapter number 4. Also, we will do exercise of chapter number 4. This is my 26th lecture, and I am your lecturer, Mrs. Saira Jamal. The topic of discussion is intermolecular forces. What are intermolecular forces? As from the name indicated, the forces of attraction created between the molecules are called intermolecular forces. Intermolecular, in between the molecules. So the forces of attraction created between the molecules are called intermolecular forces. Intermolecular forces are weaker than ionic or covalent bond. Intermolecular forces are weaker than ionic or covalent bond. The bonds are between atoms, and intermolecular forces are weaker forces of attraction between the molecules, while ionic or covalent bonds are between the atoms. There are several types of intermolecular forces, but in this grade we will discuss only two of these types. Those two types are number one, dipole-dipole interaction or dipole-dipole forces, and second one is hydrogen bonding. As in this image you can see that one hydrochloric acid molecule attract second hydrochloric molecule. So as these are two molecules and these two molecules attract each other, so a weaker force develop among these between these two molecules, and that force is called intermolecular forces, which are weak forces of attraction between the molecules. While between the two atoms, hydrogen and chlorine, the bond is covalent bond. So covalent bond is stronger than intermolecular forces. Intermolecular forces are between the molecules, while you can see covalent bond is between hydrogen atom and chlorine atom. And HCl is one molecule, and this HCl is second molecule. So the forces of attraction which we represented with dotted lines shows the weak intermolecular forces between the two hydrochloric acid molecules. Dipole-dipole interaction. What is dipole-dipole interaction? The attractive force between the positive end of one polar molecule. What is polar molecule? I told you before, when two dissimilar atoms combine together and form a molecule is called polar molecule. The molecule is polar because the two atoms have electronegativity difference. So due to the difference in electronegativity, the two atoms will get charges, partial positive and partial negative charge. So polar molecule and the negative end of the neighboring polar molecule means two polar molecules attract each other with a force. That force is called dipole-dipole force. The polar molecules are also called dipolar molecules or dipoles. A polar molecule is called dipole. Di means two, pole means they have two poles, positive pole and negative pole. That's why polar molecule is also called dipole. Two polar molecules of the same substance attract each other. Stronger the dipole-dipole forces, higher will be the other properties, like higher will be the melting point, higher will be the boiling point, heat of vaporization, etc. All these properties actually depend upon the strength of the dipole-dipole forces. So greater the differences in electronegativity level, stronger will be these forces. Coming toward the example, what is the example of dipole-dipole interaction or dipole-dipole forces? When two different atoms share electron pairs, both the atoms exert different forces on the shared electron pairs. Why the two atoms exert different forces? Because they have electron negativity difference. More electronegative atom will pull the electron pair with greater force than the other, and the less electronegative atom will pull it with a weaker force. So more electronegative atom, as it is pulling the electron more towards itself, it will draws electron density toward itself. Electron density means all the electrons it will pull towards itself. This makes it partially negatively charged. You know that when an atom gain electron, it get complete negative charge. But in this case, the atom is not taking the electrons completely, only it pulls the electrons towards itself. That's why it will not get complete negative charge, but it will get only partial negative charge, and other atom will get partial positive charge, as it will electron deficient, not completely electron deficient, but the electrons will go far apart or far away from this atom. So that atom will get partial positive charge. Such a covalent bond is called non-polar covalent bond. If the two similar atoms will combine together and they'll form a bond, that is called non-polar covalent bond. But in this case, as they have two poles, so this is polar covalent bond. Okay, non-polar is mistakenly I mentioned non-polar. This is polar covalent bond because both the molecules, in the molecule, both the atoms, they have electronegative difference. Example is hydrochloric acid. So you know that chlorine is present in group number 7 of the periodic table. And if you remember, I told you that in the previous chapter that all the halogens atoms, they are highly electronegative. They have more power to attract the electrons towards themselves. So chlorine will pull the electron more towards itself, and then in turn will get partial. This delta represent partial, okay, partial half negative charge, partial negative charge, and this delta plus means partial positive charge will appear on the hydrogen atom. Same is the case. Now you can see that the negative end of one polar molecule will attract the positive end of the another polar molecule. So by these, a force will develop between these two molecules, which is called dipole-dipole interaction or dipole-dipole forces. One dipole will attract another dipole molecule. So it is called dipole-dipole interaction. In this case, you can also see that the positive end of the one polar molecule will attract the negative end of another polar molecule. Hence, partial negative charge will appear on this molecule and partial positive charge will appear on this molecule. And one more thing, you know that same charges attract, same charges will repel each other, and oppositively charges will attract each other. So positive and negative will attract each other, while positive charges will repel each other. So chlorine will attract hydrogen of the second molecule, and hydrogen of the first molecule will attract the chloride ion or chlorine of the second molecule. This type of forces is called dipole-dipole interaction or dipole-dipole forces. Second type of intermolecular forces are hydrogen bonding. What is hydrogen bonding? The interaction of highly electron deficient hydrogen. Hydrogen is electron deficient because it has only one electron in the outermost shell, and it needs one more electron to complete its duplet. So we'll call it hydrogen electron deficient. But when if hydrogen is present in the form of proton H plus, so that in that case it is highly electron deficient, and it needs two electrons to complete the outermost shell. And lone pair on a nearby a highly electronegative atom, such as you know that in case of nitrogen, oxygen, or fluorine, lone pair electrons are present on these atoms. So hydrogen will pull the electrons, lone pair electrons from nitrogen, oxygen, or fluorine, and then in turn will make a bond which is called hydrogen bond. This phenomena is called hydrogen bonding. The bond is called hydrogen bond, but the phenomena or the process is called hydrogen bonding. Molecules in which hydrogen is covalently bonded to a very electronegative atom, such as oxygen, nitrogen, or fluorine, is also weakly bonded to a lone pair of electron of another electronegative atom. This other atom may occur in the same molecule or in a nearby molecule. So this intermolecular interaction is called hydrogen bond. It means that one water molecule can make hydrogen bond with another water molecule, and if it is not water, so one water molecule can make hydrogen bond with the ammonia or with the hydrogen fluoride as well. Oxygen, nitrogen, or fluorine makes hydrogen bond because with that hydrogen, which is very electron deficient, this interaction of such highly electron deficient hydrogen and lone pair on a nearby electronegative atom compensate for the deficiency. Deficiency of hydrogen is compensated by or fulfilled by the lone pair electrons provided by oxygen or nitrogen or fluorine. Two lone pair electrons are present in oxygen, one in nitrogen, and three in the fluorine. So they can give the lone pair electrons to hydrogen and then can compensate or can fulfill the deficiency of electrons in hydrogen atom. In this case, we have two water molecules which can make hydrogen bond with each other. You can see that the hydrogen of one water molecules is attracted by the lone pair. Here lone pair electrons are present on oxygen. The lone pair electrons on the oxygen atom and then in turn will form hydrogen bonding. Example of hydrogen bonding is water molecule. You can see here the central one is water molecule. So water can make four hydrogen bond. One water molecules can make four hydrogen bonds. Two hydrogen bonds are due to the presence of these two hydrogen atoms, and two of these hydrogen bonds are due to the presence of the two lone pair electrons. As I told you, on oxygen, two lone pair electrons are present. So one lone pair will be utilized by this water molecule, one lone pair of hydrogen of this hydrogen will pull electron from the lone pair of this water molecule, and this will pull electron pair from this water molecule. So these two hydrogen bonds are due to the presence of hydrogen atom, and these two are due to the lone pair electron. Negative charge are the lone pair electrons which are present on oxygen, on the oxygen of water, and then oxygen can give that lone pair electron to these two highly electron deficient hydrogen atoms. So then in turn, one water molecule can form four hydrogen bonds. What is the importance of intermolecular forces? Intermolecular forces are extremely important in determining properties of biological molecules. Biological molecules mean those molecules which are present in living organisms. So those molecules are proteins, DNA, and also some synthetic materials which we form artificially outside the body, like glue, paint, resins, etc. So resins and paint and glue, we prepare them in industries. Also, intermolecular forces have a huge importance in synthetic materials as well, not only in biological molecules but also in synthetic materials. The adhesive action of paints. Adhesive means to bind the two objects or two materials together. The substance which is used to bind two surfaces or two materials together is called adhesive, and the action is called adhesive action. So paints have adhesive action, dyes have adhesive action, and this adhesion power or action or property of paint and dye that is stuck on the surface on which we are applying the paint, and on the surface on which we are applying the dyes is stuck over there tightly. How and which force help them to tie on that surface or to stuck on that surface is the hydrogen bonding. Synthetic resins bind two surfaces together by hydrogen bonding or dipole-dipole interaction. Then next topic is about the nature of bonding and properties. Like if in a molecule the bond is ionic bond, so the compound which contain or which consists of ions, and those ions are joined together by electrostatic forces are called ionic bond, ionic compounds. Those compounds which contain ionic bond are called ionic compounds. And ionic bond, you know, is a type of bond which is formed by the um, attraction between the two positively charged ions. If you remember, I told you in the previous chapter that one atom or metal loses electrons to form cation, and non-metals gain electron to form anion, and these positively charged ions attract each other with a force which is called ionic bond. So those compounds which contain ionic bond are called ionic compounds, and definitely they are made up of ions. Ionic bond is also called electrostatic forces. So if in a compound or in a molecule not molecule, because ionic compound they never form molecules. So if in a compound ionic bond is present, so at room temperature most of those ionic compounds are crystalline solid. They are solid and they form crystals. Both the example are sodium chloride and cesium chloride. So cesium chloride and sodium chloride are the two examples of ionic compound, and they form colorless cubic crystal. And each, in case of sodium chloride, each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. Remember this for MCQs, it is very important. And if you see the internal structure of cesium chloride, it is different from sodium chloride, although both form crystals, but the crystals are different. Crystal of cesium chloride are different from the crystal of sodium chloride, although both are solid, but the crystal structures are different. In case of cesium chloride, each cesium ion is surrounded by 8 chloride ions. Here sodium is surrounded by 6 chloride ions, but in this case each cesium ion is surrounded by 8 chloride ions, and each chloride ion is surrounded by 8 cesium ions. So this is the main difference between the two types of crystal, although both are ionic compounds. Thus, in crystal, each ion is attracted strongly to each of its neighbors. So definitely one ion will attract the oppositively charged ion strongly. The large attractive forces result in a very stable structure. So if there will greater electronegativity difference between the two ions, so they will attract each other with a stronger force, and then they will form a stable molecule, a stable structure. So ionic compounds, due to their strong forces of attraction, they are very hard and they have very high melting points. Like suppose, like for example, the melting point of sodium chloride is 801 degrees centigrade, which is too much. Now, as I told, in case of the sodium chloride, you can see the blue balls and the red balls. So the red balls are for sodium and the blue balls are for chloride ions. So chloride ions atomic chlorine atomic number is 17. That's why the size of chlorine is greater than sodium, which has atomic number of sodium is 11. So atomic number of like the size of chlorine is chloride ion is greater than that of the sodium. Now, as I told you, that in case of this crystalline structure, cubic structure, you can see that one chloride ion is surrounded by 6 sodium ions. So you can see one at the right, two left, three up, 4 down, and then 5 back, and 6 in front. So these are the 6 sodium ions which surround one chloride ion. One chloride ion is surrounded by 6 sodium ions. Right, left, top, bottom, back, and front. Same is the case of sodium ion. Each sodium ion is surrounded by 6 chloride ions. The same thing, left, right, top, bottom, back, and front. So 1, 2, 3, 4, 5, 6. One chloride ion is surrounded by 6 sodium ion, and one sodium ion is surrounded by 6 chloride ions. So both the ions, they have same uh, distribution of ions. In case of the cesium chloride, as I told you, cesium and chloride, you can see here that one cesium ion is surrounded by 8 chloride ions. Now you can see, let's see the number of chloride ions. So we have one. So this is, suppose we have cesium. So cesium is surrounded by 1, 2, 3, 4, 5, 6, 7, 8. 8 chloride ions surrounded one cesium ion. In this case, one chloride ion is surrounded by 8 cesium ions. Let's count: 1, 2, 3, 4, 5, 6, 7, 8. So one chloride ion is surrounded by 8 cesium ions, and one cesium ion is surrounded by 8 chloride ions. So that is the main difference between the cesium chloride crystalline structure and the sodium chloride crystalline structure. In the sodium chloride, each sodium is surrounded by 6 chloride ion, and each chloride by 6 sodium ion, while in cesium chloride, each cesium is surrounded by 8 chloride ion and each chloride is surrounded by 8 cesium ion. Then next topic is about the conduction of electricity through ionic compounds. As you know that if the compounds, if they contain ionic bond, they are called ionic compound, and ionic compounds are made up of ions, so they have ions. For the conduction of current, the important thing is free ions. If free ions are present in a compound, then that compound will be able to conduct electric current. If free ions are not present, that compound is unable to conduct the electric current. So the presence of free ions are compulsory. In ionic compound, ions are free in molten state. In molten state means when we melt sodium chloride. So when after heating sodium chloride, it will melt out, and after melting, the ions will be free. Sodium ions and free chloride ions will be there. Then if free ions are available, then definitely they will conduct electric current. When electricity is applied or when voltage is applied, sodium ion will move toward an electrode called negative electrode, which is also called cathode, and chloride ions will move towards the positive electrode, which is called cathode. Electrodes are actually the electrical, the metallic rods, and they have positive or negative charge, and then oppositively charged ions will move toward those electrodes. Movement of ions are responsible for flow of electricity between the electrodes in the external wire. External wire is attached with the battery or with this cell. And if we have molten sodium chloride or aqueous solution of ionic compound means when we dissolve the ionic compound in water. Aqueous come from aqua means water. When we make solution of ionic compound or sodium chloride or salt in water, in that case also the ions will get free, and those free ions will then conduct electric current. So we can get the free ions of ionic compound by two ways: by melting them, and secondly by making their solution in water. You can see in this image we have these two electrodes. This is positively or positive electrode, which is called anode, and negative electrode, which is called cathode. They are made up of specific material, and that material make them anode and cathode. We will learn about the detail inshallah in first year. So this one negative electrode is called cathode and the positive electrode is called anode. And this is the external wire. The wires are connected to battery. And in solution, in beaker, in solution there is a aqueous solution of sodium chloride, sodium Na plus ion and chloride minus ion. So minus ion will attract it toward the positive electrode, and the positive ions will be attracted towards the negative electrode, because I told you that the oppositively charged species or ions or substances will attract each other. And this form, what will happen? The chloride ion will loses electron on this electron, and those electrons will then move from anode towards cathode. Electrons will move from anode towards cathode. How electrons will move? Through this wire. This is external wire to which the electrodes are attached. This is called internal system, and the wire is called external system. Ions are moved in internal system, like from you can see from solution it can go toward the anode and through the cathode. But electrons, they always move from in external circuit, and external circuit is that of the external wire. So electron will move from anode towards the cathode. You can see this arrow show. This arrow shows the movement of electrons from the positive electrode towards the negative electrodes. And the battery actually provides voltage. After providing voltage, this reaction will take place. The ion will move towards a positively charged electrode, and the electrons will move from anode towards cathode. Next is society, technology, and science, which is the last topic of this chapter. Uses of adhesive or synthetic. Synthetic means which we artificially make in industries, so they are called synthetic. What are adhesive? Adhesive means a substance used for sticking objects or materials together. If we want to stick two materials together or join two materials together, then we use what? We use glues. What are glues? Glues are adhesive. So adhesive means substances which are used for sticking objects or materials together. We have synthetic adhesive. Synthetic adhesive means which we prepare in industry, such as, for example, glues, epoxy resins are used in large-scale industrial application. Glue are cheap. They are less costly than the synthetic adhesive like the epoxy resin. They are expensive. So glues are extensively used as an adhesive for wood. Which type of wood? Vinyl, polyplywood, corrugated cartons, and laminated board are these are wooden materials or wooden substances, and they are joined together by using wood glue. You can see in this image all these are different types of wood glues which are used in the assembling of uh, wooden parts. Glues for glass and metal are also available, like to join the glass pieces or glass parts. There are also glues available even for metal. A different type of glue are available. So there we have different types of glues depending upon you are they are required for which purpose or which type of substances or materials. Epoxy resin. Why are they called epoxy resins? They are called epoxy resin because they contain epoxide group. They contain epoxide group. So due to that group, they are called epoxy resins. Epoxy resins are used where water resistance is required, where you want waterproof substances. So for waterproof substances, we use this epoxy resin, not the ordinary paint. We use a special type of paint which is called waterproof paint, or they are called epoxy resins. They are mixed in paint and then they increase the hardness or stickiness of the paint and make it strong, and they form a strong and tough coating. They also give flexibility and chemical resistance. The paint is even resistance toward chemicals, like chemical will not react with the paint. For these reasons, dam, bridges, thermal power stations all are coated with this type of paint, which contain epoxy resins in them. Modern aircraft, automobile use epoxy resin adhesive for assembling. Assembling means joining or sticking their parts, for saving money and reducing weight, because they are cheap. So that's why saving money and reducing weight. They are lighter in weight. Hence, there is a need of more adhesive. We need more adhesive. The reason is that I told you they are water resistant, chemical resistant. Water cannot react with these epoxy resins, and the chemicals cannot react with them. So the bridges, dams, thermal power station, on all we use these type of paints which contain epoxy resins in them. As I told you that the epoxy resin contain a special type of group in their structure which is called epoxide. You can see in this image this R alkyl group, two carbon atoms are attached with oxygen atom, and this is another alkyl group. So this type of structure is called epoxide group. Epoxide group is present in epoxy resin. Inshallah, about these structure you will learn in grade 10. These are some of the example of the paints which contain epoxy resins in them, and they have very tough power, strong coating power, water resistant, chemical resistance, and lighter in weight, and they are used for assembling even the aeroplane, aircraft parts, automobile parts, bridges, dams, all are for all the purposes we are using these type of paints because they have very tough and flexibility and chemical resistance, and they have strong and tough coating. So this was all about the chapter, and inshallah about the next lecture we will do the exercise of this chapter. Until then, take care. Allah.